Hi everyone! Today I'm going to be talking to you about a substance called germanium. Let's use the whiteboard to explain. So first, what is germanium? Germanium is a semiconductor, but what is that? Let's start off by using the periodic table. We can see here that germanium is in group 4 of the periodic table along with silicon. All semiconductor materials like silicon or germanium have a unique property. All of them have 4 electrons in their outermost orbit. All the 4 electrons form perfect covalent bonds with 4 other atoms creating a lattice to form crystals. A semiconductor is a substance that has specific electrical properties that enable it to serve as a foundation for computers and other electronic devices. Semiconductors are an essential part of electronic devices. They enable advances in communications because they're used in various technologies such as satellites and phones, as well as computing, healthcare, military systems, transportation, clean energy, and various other applications. As its name implies, a semiconductor is a material that conducts current, but only partly. It is materials which have a conductivity between conductors and insulators. Now that we've covered what they are, how do semiconductors work? There are actually 2 types, intrinsic and extrinsic. Germanium and silicon are the most common types of intrinsic semiconductor elements. They have 4 valence electrons, and so they are tetravalent. They are bound to the atom by a covalent bond at absolute 0 temperature. When the temperature rises due to collisions, few electrons are unbounded and become free to move through the lattice, thus creating an absence in its original position, known as a hole. These free electrons and holes contribute to the conduction of electricity in the semiconductor. In extrinsic semiconductors, the conductivity of the semiconductor can be greatly improved by introducing a small number of suitable replacement atoms called impurities. The process of adding these impurity atoms to the pure semiconductor is called doping. Now, extrinsic semiconductors can also be classified as N-type semiconductors and P-type semiconductors. A P-type semiconductor is a type of extrinsic semiconductor which is obtained by adding a trivalent impurity in an intrinsic or pure semiconductor, trivalent being an impurity which has 3 valence electrons. Examples of trivalent impurities are aluminum, gallium, and indium. An N-type semiconductor is also a type of extrinsic semiconductor, which is obtained by adding a pentavalent impurity, which is an impurity which has 5 valence electrons. This is added to an intrinsic semiconductor, just like the P-type semiconductor. Common examples of pentavalent impurities are antimony, arsenic, bismuth, etc. Now we know a bit more about semiconductors, let's get back to germanium. The largest use of germanium is in the semiconductor industry. When doped with small amounts of arsenic, gallium, indium, antimony, or phosphorus, germanium is used to make transistors for use in electronic devices. Germanium is also used to create alloys and as a phosphor in fluorescent lamps. Both germanium and germanium oxide are also being used in infrared optical instruments, as well as infrared detectors. Some germanium compounds are even seen to be effective in killing some types of bacteria and are currently being studied for use in chemotherapy. That's the end of my presentation on germanium. I hope you learned something new. Thank you.